This is example 3.5.6. It says determine the acceleration of a car that can go from 0 to 60 over the course of 1,300 meters. Now that's how some sports cars are rated and how fast they can go from 0 to 60, 0 to 100. So what they're actually measuring is the acceleration of the car. So we're going to go ahead and take that acceleration and we're going to calculate it, but what we're going to do is we're going to do it in standard units. So we are looking for acceleration, that is correct, and we are using IFDAT as our guiding principle. So let's go ahead and say we've got initial velocity, final velocity, and distance, acceleration, and time. Okay, our initial velocity is 0, and that matches up with what we want it to be. We have 60 miles per hour. Now we're going to have to convert that, and you should remember what that is because we've used it so often, but we will convert it again here. You have 1,300 meters. We are trying to solve for the acceleration, and there is no time that is given. So we're going to go ahead and say that's the one thing that we're missing. So our equation is A equals VF squared minus VI squared divided by 2 delta D. So let's go ahead and convert real quick. Let's draw our picture first. So we have an initial velocity of 0. We have a final velocity that's going to be some number that we're going to calculate, and this all occurs over 1,300 meters. Now, since our initial velocity is at 0 and our final velocity is positive, we know that we're going to have to go ahead and say that the acceleration is going to be positive. It just kind of lets us know what to expect. So now, 60 miles per hour, and we convert 1 mile 4 times around the track, 1,609 meters. Okay, 1 hour is 3,600 seconds. So that ends up being 60 times 1,609 divided by 3,600 is 26.8 meters per second. So now our equation is in the exact form that we want it to be in. A equals VF squared minus VI squared divided by 2D. So now we just plug our numbers in. We're going to say A is equal to 26.8 minus 0 divided by 2 times 1,300. So now, oh, excuse me, I forgot the square term. So 26.8 squared divided by 2 times 1,300. And when you do that, you get an acceleration of 0.276 meters per second squared. So let's just check our units to make sure that they are valid. Acceleration is measured in meters per second squared. On the other side we had meters per second, and that value was squared, and we divided that by meters. Meters squared per second squared divided by meters. One of those meters cancels with one of those square terms, and what we're left with is meters per second squared equals meters per second squared.